Okay, class, today we're going to start with chapter 7. Chapter 7 is very long, so we're going to do half of the chapter in this video and half of the chapter in the second video. So we're going to start with chapter 7a. I'm going to assign some homework and then I'll assign chapter 7b in a couple of days, okay? So we're going to start now with, we did some pre-algebra in chapter 6, and today we're going to do basic algebra. No big deal again, just some very basic algebra, how to manipulate formulas and so forth. But we need to start off with how and what we're looking at, okay? One thing we're looking at is an expression. An expression is a general name for any collection of numbers and letters that are connected by an addition sign, arithmetic sign. So for example, x plus y is an expression. 2x squared plus 4 is an expression. 3 times x squared minus 2ab is an expression. And the square root of x squared plus y squared is an expression. So all of those are examples of expressions. Now, if that expression has been formed by multiplying quantities, each multiplier is called a factor of the expression. So again, if the algebraic expression has been formed by multiplying quantities, each multiplier is called a factor. So let's look at what a factor is. Okay, so if you have, I'm just going to do it like this. If you have an expression and you have a factor, or what are the factors, okay? This will be easier to explain. So if you have an expression AB, and remember that's anything that's numbers and letters with an arithmetic sign or some kind of sign. So this A and B would be the same thing as A times B or A dot B or just AB, okay? So the factors of that is going to be the algebraic expression has been formed by multiplying quantities. Each multiplier is called a factor. So each one of these is called a factor. So A and B are factors. What about this one? 2x times x plus 1. You might also see that as, well, x is not multiplication. That's just 2x, okay? So your factors would be 2x, okay, and x plus 1. That would be one way. But you also have these two factors, so that would be a 2 and an x and x plus 1. So you have all those factors, okay? What if you had this? R minus 1 and 2r plus 1. So r minus 1 would be a factor and 2r plus 1 would be a factor, okay? Now, the algebraic expression can also be a sum or difference of a simpler quantity. Quantities that are added or subtracted are called terms. So now let's look at a one called terms. So you have expression, which is the whole expression. You have factors, which is what you multiply each one by. And then you have something called terms. So let's look at terms. So if you have this, we're going to have an expression. We're going to have a term. We could even have factors, okay? So what if we had this expression, x plus 4y? What would our terms be? Well, our terms would be x and 4y. Now, the first term is x, and the second term is 4y. And the reason is, it's because it's looking at a sum or addition, okay? So with a term, it's going to have a plus or a minus in between it. So this wouldn't be a term, 4y. That would be a factor, 4 and y. Okay? So if we put factors here, our factor in this case would be 4 and y. Okay? Or just 4y. Now, what if you had this? 2x squared plus xy. Okay? Again, for terms, you're looking at it as positive or net, or if it's a plus or a subtraction. So our terms are going to be 2x squared and xy. Okay? Now, if we were looking at factors, our factors would be 2x squared and xy, or it would be 2 and x squared and x and y. Okay? Now, what about a minus r? A minus r, your terms will be a and r. And there wouldn't be any factors because there's no multiplication. Okay. So just practice those and look at that. Now, a formula is a rule for calculating the numerical value of one quantity from the values of the other quantities. So now we're going to look at a formula. And you're used to formulas. Formulas would be like V equals I times R, Ohm's law. We'll talk about that one in a second. So a formula is a rule for calculating the numerical value of one quantity from the values of the other quantities. Okay, so for example, Ohm's law. Ohm's law states the voltage V in volts across a simple resistor is equal to the product of the current in amperes through the resistor and the value of its resistance R in ohms. So our formula is V equals I times R. So when we're evaluating formulas, we would need to know either what V equals, what I equals, or what R equals. So you would need two of these to be able to solve this equation, whether it's V and I, or I and R, or R and V, okay? And you can look at the other ways to write this. I would equal V over R, and R would equal V times V over I, and then, of course, V equals I times R, okay? Now, evaluating a formula or algebraic expression means to find its value by substituting numbers for the letters in the equation. So if we had like V equals 20 volts and I equals 20 milliamps, then you could find R, okay? And we'll do some examples in just a second. So what you do is you follow two steps. Step 1, you place the numbers being substituted in parentheses and then substitute them in the formula. Step 2, you do the arithmetic carefully after the numbers are substituted. So for example, and don't forget, you have to use PEMDA rules. PEMDA rules still apply here, okay? So let's look at an example. So what if we had this? The following formula is used to calculate the number of joists J needed to cover a distance L when space is 16 inches to the center. So our formula is J equals 3/4 L plus 1, okay? So the following formula is used to calculate the number of joists needed, joist is J, to cover the distance L, the length, when spaced 16 inches from center. All right, so suppose you know that L equals 44 feet. You can determine J as follows. So first you substitute L for 44. So J equals 3/4 times 44 plus 1. So you put the number you're substituting in parentheses to keep it separate. Then do the arithmetic according to the order of operations. So first, by order of operations, we need to multiply 3/4 times 44. And when you do that, J equals 33 plus 1. So then you add 33 plus 1, and J equals 34. So you need 34 joists needed for that given length. Okay? So you just write down what you need, write your formula, write down what you have, and see what you need. Okay? Let's look at another example. What if you had this formula? T equals H times A plus B over 2. Okay? And we know that H is going to equal 2.5 inches. A is going to equal 3 1/4 inches. And B is going to equal 4 3/4 inches. So you plug all that in. So we have T equals H is 2.5. So 2 times 2 is 4 plus 1 is 5/2. Just go ahead and put it in fraction form. A is 4 times 3 is 12 plus 1 is 13. So that's going to be 13/4. Plus B is 4 3/4, so it's going to be 16, 17, 18, 19/4. Okay, and then all that's going to be divided by 2. So then we do the parentheses first, so that's going to be 5/2 times. When you do this, that's going to be 32nd fourths. All that divided by 2. Now, 2 and 4, you need to find a common denominator. So that's going to be, if we use 4 here, 2 will go into 4 2 times. 2 times 5 is 10. So that's going to be 10/4. 32/4. Whoops. Fix that. Okay. Now, when you reduce this, that's going to be, reduce it there by 2, that's going to be 1, that's going to be 8, times 5 is 40. So that's going to be 40 halves divided by 2. And when you do that, you're going to get 20 halves. And 20 halves is 10 square inches. Okay? So with that, you're going to need 10 square inches. T equals 10 square inches. And that's really, you know, it. But let's work a couple more. So in this example, L equals 2 times the square root of 2RH minus h squared. Take the square root of that. So again, you got to use PEMDA. So you do everything under the parentheses first, then take the square, under the square root first, then take the square root and multiply it by 2. Our values are R equals 6.5 feet and H equals 4 feet. So we'll go in and plug that in. So it's going to be 2 times R. R is 6.5. And I just leave the units off until the end just because it's cleaner. H will be 4 minus 4 again squared, and take the square root of that. So now we do the underneath multiplication. First we got to do the square root, or the square, right? So that's going to be 2 times 6.5 times 4 minus 16. Okay, lift the 2 off. Don't leave the 2 off. So then that's going to be, still working under the parentheses, 2 times 6.5 times 4 is going to be 52 minus 16. Then we have to do the 52 minus 16. It's going to be 36. Take the square root of 36 and multiply it by 2, and you get 12 feet. So y'all stop that there and try to work that problem and make sure you get that, okay? If you have any questions, let me know. All right, the next type of problems we're going to look at is conversion for temperature. And there's a couple of formulas for that. Celsius is going to be 5 times the Fahrenheit minus 32 divided by 9. And to find the Fahrenheit, that's going to equal 9 degrees Celsius divided by 5 plus 32. Okay, so these are your conversions that you need to know to do the conversions, okay? And I'll give those to you on the test. So what if we have this? 650 degrees Fahrenheit equals, we want to know what that's going to be in Celsius. So how do we do that? Well, we use our formula for Celsius. Celsius equals 5 times Fahrenheit. Our Fahrenheit value is 650 minus 32 divided by 9. So we got to do 650 minus 32, which is 618, divided by 9. 5 times 618 is 3090, divided by 9. So that's going to approximately equal to 343.3 degrees Celsius. Okay? Now our next type of number so our next type is going to be negative 160 degrees Celsius equals Fahrenheit. So now we're going to convert it to that. So Fahrenheit equals 9 degrees, or 9 minus Celsius, divided, no, I'm sorry, it's not minus. Z 5 plus 32. Okay. All right, so we're looking for negative 160. So that's going to equal 9 times negative 160 divided by 5 plus 32. So 9 times 160 is going to be negative 1440 divided by 5 plus 32. So now you have to do negative 1440 divided by 5, which is minus 288 plus 32. And that's going to equal negative 256 degrees Fahrenheit. Okay, so that's how you do your temperature conversions. So not too hard, and I'll give you the conversions on the test, so you should be fine in doing that, okay? All right, so the next thing we got to do is adding and subtracting algebraic expressions, okay? So if you have two algebraic terms that are to be alike, they're called like terms. Like terms. If they contain exactly the same literal parts. So for example, if you have 2x and 5x, these would be considered like terms because you have a numeric part and you have a literal part. Okay, same thing here, numeric and literal. And if you notice, they're the same. Okay, so for some more examples, 3xy squared and plus 7xy squared are like terms. Their literal parts, xy squared, and their numeric parts, 3 and 7. Okay? But what about this? What if you had 3x squared and 2x? Are they like? No, they are not. So they're unlike terms. If they were like terms, it would have to be 3x squared and 2x squared, or 3x and 2x. Those are like terms, okay? And you have to pay attention to that because when we start adding and subtracting, you can't add and subtract these two, okay? So let's look at an example. What if we had this? What if we had add 2x plus 3x? Those are like terms because they're the same, aren't they? So in that case, that's just going to be 5x. What if you had this? 8ax squared minus 3a squared x. 8a squared x minus 3a squared x. Again, a squared x and a squared x, they're like terms. So you just subtract 8 minus 3, which is 5. And that's going to be a squared x. Okay? Now, what if you had this one? What if you had 3y plus 1 plus 9y plus 1? That's a y, not an x. Okay? How would you add that? Well, 9 plus 3 is 12. And then it's just going to be y plus 1. I'll show you in a minute how to go through that if we were finishing that problem, okay? All right, what if we had this? 4x y minus xy plus 3xy. Okay, so what are you going to do with this? So xy, xy, xy. Now, when you have 4xy minus xy, that's the same thing as saying 4xy minus 1xy. That 1 is just known to be there, okay? But if it helps you, put that there. Plus 3xy. So 4 minus 1 is going to be 3. 3 plus 3 is 6. So it's going to be 6xy. Okay? Now what do you do if you need to simplify a series of terms being added or subtracted? So what if you had some terms that were not alike and you had to add or subtract them? So what if you had this? 3x plus 4y minus x plus 2y plus 2x minus 8y. You need to go through here and group your like terms. So we've got 3x here, we got x, and we got 2x. And then we got y, y, and y. So we need to group those together. So first we have 3x, then we have minus x, and make sure you put those minus and plus signs there with it, okay? Plus 2x, that's all one group. And then you have plus, the first one you have is 4y plus 2y minus 8y. Okay, so now they're all grouped together. So then you can do your addition and subtraction. Okay, so 3x minus x, remember that's an imaginary 1 there. It's 2x plus 2x is 4x. Plus, now we got 4 plus 2 is 6, minus 8 is minus 2y. Or you can write it like this, 4x minus 2y. Okay, so you group them together and then do your add or subtract. Let's look at another one. What if we had this one? 3ab squared plus a squared b minus ab squared plus 3a squared b minus a squared b. Okay, so now, first of all, you group them together. So we have 3ab squared, and the other ab squared we have is just this one. So it's going to be minus ab squared. Plus, then we have a squared b, and then we have 3a squared b, and then we have minus a squared b. Okay, just make sure you put your plus and minus where they go, okay? So 3 minus 1 is going to be 2ab squared, plus, this is just a 1 in front of it, so 1 plus 3 is 4, and 4 minus 1 is 3, so that's going to be 3a squared b, and that's our answer. Okay, so just group your like terms and then do your add and subtraction. Now, what about expressions with parentheses? All right, so we know we got to use PEMDA. Rule 1, if the parentheses has a plus sign in front of it, remove the parentheses. So if you had, let's see, for example, so rule 1, if it's a plus sign, remove parentheses. Okay, so let's look at that. So what if we had 1 plus 3x plus y? So we want to get rid of the parentheses. So it's got a plus in front of it, so that's just going to be 1 plus 3x plus y. What about this one? What if you had 2 plus a minus 2b? Again, you're just going to move the parentheses. 2 plus a minus 2b. Okay? Rule 2. If the parentheses has a negative sign, change the sign of each term inside and remove the parentheses. So if it's a negative sign, change the sign of each term and remove parentheses. Okay? So, let's look at that one. So, what if we had 2 minus x plus 2y? Okay, so it says if you have a negative sign, change the sign and remove the parentheses. So, 2 minus x, it's going to be 2 minus x minus 2y. So, you change each term inside of the parentheses. What if you had this one? I don't know why it does that all the time. A minus 2x minus y. So that's going to be a minus 2x, and you change each one. So that's a negative, so that's going to be an addition, plus y. Where this one was positive, so you change it to negative. So you change it opposite inside the parentheses. Okay? Rule 3. Rule 3 states that if the parentheses has a multiplier in front, multiply each term inside the parentheses by the multiplier. So if it has a multiplier in front, like a number, you multiply each term inside by that number. Okay? So what if you had this? What if you have plus 2 a plus b? That's just showing that it's positive. Usually we drop that, right? So that's going to be 2 times a plus 2 times b. Okay. Well, if you have this one, minus 2x plus y. In this case, you're going to have to multiply all this. Minus 2x and minus 2y. Okay. Let's look at another one. What if we had minus x minus y? So that's going to be minus x. Of course, that's a negative one, right? Remember, that's just known, but for now, we'll put it in there. X minus y. So that's going to be minus x. Minus 1 times minus y would be positive y. So minus x plus y. Okay. Let's look at another one. What if we had this? 2 times 2x minus 3y. That's going to be 2 times 2x plus 2 times minus 3y equals, that's going to be 4x plus 2 minus 3, it's going to be minus 6y, or that would actually be written like 4x minus 6y. Okay, let's do another one. X squared minus 3 times x minus y. Remember, the more of these you do, the quicker you'll get at it, okay? So x squared, now minus 3 times x is going to be, we'll put plus minus 3 times x plus minus 3 times minus y. And that way you can see exactly. But if you get better, you can just say minus 3x minus 3y. So x squared, so that's going to be x squared minus 3x. You can drop that plus there. And then minus 3 minus y. Remember, a negative times a negative is a positive. So that's going to be plus 3y. So it's going to be x squared minus 3x plus 3y. So I'm going to stop there for this first half of the video, just so it's not so long, because it takes forever to upload these. And be watching for the second half of the video coming up soon in the next day or two. And I'll post the homework on Blackboard, okay? Thank you, guys. Have a good day.